This is the Kiwo Expo Check. It is Kiwo's exposure calculator. It comprises of 4 films, and if you look over here, I have the films actually placed up on the chart here. I mentioned it has 4 films. It has a coarse line film, a medium, and a fine. If you look at it, the coarse film would be used for coarse meshes. If you're using a 110 mesh, for example, oftentimes white mesh, the thread diameters are so large that it would be very difficult to resolve fine detail. Many of the film positives, or I should say the exposure calculators on the market, utilize a very fine detail in their design of their calculator. But using coarse mesh, you wouldn't be able to pick up that fine detail. So we've integrated 3 different films: coarse detail for 110 mesh and below, medium detail for 110 to about 260 mesh, and fine detail film for 280 and above. Now, what you do is actually sandwich it with an exposure scale, which is a neutral density filter with 10 steps on it, and I register it with the R, and I'm actually going to put it on the opposite side, the back side of the film, but you can see how we're masking the 10 images with varying degrees of filtration. What this is going to do after I expose the screen for double what I think the proper time is, this will give me 10 unique exposures with only one screen frame being exposed. Now, to recap, we have done a step coating test to identify the proper thickness and smoothness of the emulsion coating. We selected the coating technique that achieved our optimum thickness and smoothness. We then coat a second screen so that we can do an exposure calibration test utilizing the Kiwo Expo Check calculator. I'm going to use the resolution calculator with the exposure calculator. Using the resolution calculator in front, I register with the R and place it face down onto the emulsion. Tape it in place and prepare to do our exposure calibration. In order to get effective results, we need to expose this screen for twice the amount of time that we believe the proper time is going to be. Okay, now that I've got my exposure calculator taped in place, I'm using a 380 31 micron mesh, and based on my experience, I know that with our 8,000 watts light source, proper time usually falls in at about 60 to 80 seconds, so I want to double that. So I need to go about 120 to 160. Let's call it 150. I'm going to shoot this for 150 seconds and see how it turns out. Okay, we've exposed our calculator, our Expo Check, and want to develop it. We develop it by rinsing both sides. I start with the substrate side. With the squeegee side also right away. Different techniques of washing out and developing. Our emulsions have a very strong wet resistance, and we like to utilize a pressure washer. Some people will wet it and leave it sit for a minute to allow the emulsion to soften and swell a little bit, so that when you do develop with water, that the unexposed emulsion rinses out a little bit easier. Other people will utilize a pressure washer right away. They'll just wet both sides of the screen and then pressure wash it right away. We do like the pressure washer, especially if you're doing fine detail. we're advocates of drying the screen properly, the emulsion properly prior to exposure, exposing it fully, and then using a pressure washer to develop the screen. That way we will get our highlight dots to rinse out very cleanly, and with the wet strength resistance that we have with our emulsions, our shadow dots will still anchor to the mesh fine. So continue. Show that I can develop it with a pressure washer as well. So I want to step in and use the pressure washer and do a final rinse with that. No scum or film will be left in the image area. And just to illustrate just how strong the emulsion is, I'll try to go in at a closer range to see how close I can get without damaging the emulsion. So you can see that the exposed area of the emulsion was not damaged by the pressure washer, even at fairly close range. The key to that, again, just to review, is to have the emulsion dried very thoroughly and then exposed fully. If you do succeed at doing those two things, the emulsion, especially if it's a diisophotopolymer style, which is what we're using here, a dual cure emulsion, are typically very resistant. Okay, I'm going to take the screen, put it into the drying cabinet, let it dry totally, and then we'll evaluate it on a light table to look for resolution and identify optimum exposure time. Okay, what we're looking at here is the ExpoCheck exposure calculator that we shot for 150 seconds. With the gray filters included in the film, you can see and identify where the filter was attached. In this section here, you can see the box, and you can see the box here where the filter was mounted onto the film. And what you want to do is look step to step to step and identify where you can no longer see a color difference, color change between the arrows or from one step to the next step. So if you look at the point 1, obviously there's a color change. The point 2, there's a color change. Point 3 is getting less and less, but point 3, there's still a little color change. And even point 4, it's hard to see, but there's a little bit of a color change there. No more color changing from point 5 to point 6. So at that point, I'm going to choose the point 5 factor as the optimum exposure time. That is indicated by no color change, which means that there's been no emulsion removed or washed away from the squeegee side of the screen, and that's why the color is the same as the background or non-filtered area of the film positive. So for best durability on printing, fewer pinholes, less difficulty in reclaiming, long-run durability, you want to pick the factor that you have no color change, and that would be a factor 0.5. So 0.5, we are going to multiply that by our exposure time of 150 seconds, and the result is 75 seconds. So our new exposure time using this mesh count and this emulsion coating combination is 75 seconds. Now, one thing to keep in mind, we have not examined it under a microscope. We want to identify the detail within this film to make sure that the detail that is required of us in our production run is no finer than any of the detail on this step. If the detail on this step is closed in at all, we may have to pick a step that's a little bit less exposure time, and we would look at it with a microscope to identify if I'm holding better detail with slightly less exposure. If that detail is required in my production run, I would then be forced to pick a step like 0.4 or 0.3 in order to hold open the detail. But in this case, we examined the 0.5, and we were holding an 85 line halftone 10 to 90% just fine, so we believe that the 75 seconds will work for our application.